Okay, so we we saw the in the last lecture we saw the geometric return, um, the comparison, the arithmetic average on that same set of data. All we're doing is we're going to sum up these returns. So we add the 10 to the -5 and the 20 and the 15, and we divide that before and we get 10%. So recall uh, the geometric average was 9.58%. So, um, so the U.S. equity risk premium. So here's historical and international perspective. So over the period we were discussing, 1926 to 2017, the U.S. equity risk premium has been fairly large. In earlier years, if you go back to 1802, we were looking at a risk premium around 5.4%. From 1900 to 2010, international equity risk premium was the 6.9% versus 7.2% for the U.S. So, but uh, the you know going forward, the book seems to think that 7% seems to be reasonable, although somewhat higher or lower numbers could be considered rational as well. Um, the final topic is the financial crisis. So the this slide shows the from January through December, uh, the return for the S&P 500 over the financial during the financial crisis. 6% loss in January. There were actually already losses that had begun to occur before 2008. Toward the financial crisis, actually, the first signs were that occurred were in the summer of 2007, and they just came to a head in 2008. So I believe the average return or average loss for the year for the S&P 500 was in the neighborhood of 30%. I could be slightly off on that, but a fairly historic year in terms of loss. So, okay, so into the chapter here, quick quiz. Which of the investments discussed had the highest risk, highest average return and risk premium? That would be small company stocks. Um, and which the investments discussed has the highest standard deviation? That again would be small company stocks. Why is the normal distribution informative? Normal distribution gives us a fairly simple way to analyze the risk and probability of returns. It's the normal distribution is certainly not perfect. It's not a perfect match uh, for the investment returns, but it is the simplest. There's been attempts to use much more complex returns. However, they have not proved to produce any more reliable analysis. So, the difference between arithmetic and geometric averages. So, the arithmetic average is you sum up the observations and you divide by the number of observations. The and then the geometric average is we multiply 1 plus each of the returns by each other, and then we take the root. In our example, we had 4 observations, so we took the 4th root, subtract 1, and that gives us our return. The arithmetic average tends to be overly optimistic over long time horizons, and geometric averages tend to be overly pessimistic over short horizons. So uh, we generally will look at both. So that is the end of chapter 9. I'm sorry. 10.